Okay, so this is for section 3.3, which is the mass percentages from formula. So we can find the mass percentages of each element, or we can find the mass percent of a solution or a compound in a solution or that type of thing. So mass percent in general, or percent in general, is where I have the part over the whole times 100. So for mass percent, it's the mass percent of A versus the mass of A. So whatever A is, it's what you're finding the mass percent of over the mass of the whole times 100. And so you can also calculate the mass from the percent composition, which is the mass of A. This is equal to the mass of the whole times the percent composition divided by 100. So it's basically just this equation rearranged. And this equation right here that I'm circling is, in fact, given to you on the formula sheet. It's the first formula from this chapter given to you on the formula sheet. So now let's do some examples. So number 50 in the textbook says that a 6.01 grams of aqueous solution of isopropyl alcohol contains 3.67 grams of isopropyl alcohol. What is the mass percent of isopropyl alcohol in the solution? So as always, we're going to start this problem out by taking the numbers and identifying what they are. So 6.01 grams of aqueous solution, that's a mass because it's grams. We have a 3.67 grams of isopropyl alcohol. And also included in that, just not pulling out the number, but what is the question? The question is, what's the mass percent of isopropyl alcohol? So that one has a question mark. Since this is a mass, since it tells you it's a mass percent, you have to identify then which one's the whole and which one's the part. Okay. So if I look at these two things, what I have masses of, the aqueous solution is going to be what, and the isopropyl alcohol is going to be what. And typically, if you remember the formula from the previous page, it said the mass percent of A is equal to the mass of A. So when it tells me, so my clue is when it says the mass percent of this, okay, that's going to indicate what my part is, and the other thing must be my whole. Typically, the larger number is the whole, and the smaller number is the part. So in that case, then, the 6.01 grams of aqueous solution is the whole, and the 3.67 grams is the part. So the formula then is the mass percent of alcohol, isopropyl alcohol, is equal to the mass of isopropyl alcohol over the mass of the solution times 100. So since this is what I'm looking for, and this is by itself already, all I have to do is plug in the numbers. So it's going to be 3.67 divided by 6.01 times 100. And I end up with a mass percent is 61.1% is then the unit for this problem. All right, going on to a little bit different one. 51 and 52 are also like this, but very similar, so I'd skip those. So 54 says that seawater contains 0.0065% by mass of bromine. They want to know how many grams of bromine are there in 2,563 grams of seawater. The book gives this to you problem as a volume and a density, so you have to find the mass of seawater. I didn't want to convolute this problem by doing so, so I went on and changed it to mass for you. So again, we need to find out what we have. We have a mass percent is 0.0065%. We have mass of bromine is what we're looking for. And the mass of the seawater is 25.63. I didn't say mass percent of what, but you see here it says of bromine. So bromine is going to be the part or the whole. It's going to be the part because it's the mass percent of bromine. So again, the formula is mass percent of bromine is equal to the mass of bromine over the mass of seawater times 100. I want to solve this for the mass of bromine, so that means I have to get this by itself. So the first thing I'm going to do is I'm going to multiply both sides by the mass of seawater. When I do that, I get mass of bromine is equal to mass of seawater is equal to the mass of bromine times 100. Still solving for the mass of bromine. So again, I want to isolate this or make this the only thing that's on this side of the equation. So if this is multiplication times 100, I need to divide by 100 on both sides. So I end up with the mass of bromine times the mass of seawater divided by 100 is equal to the mass of bromine. And now I can put my numbers in. The mass of the bromine was 0.0065. The mass of the seawater was 2,563 grams divided by 100. So I get the mass of bromine is 0.17 grams of bromine. I can also apply this to chemicals in a chemical formula. And so number 58 and I believe 60 both do calculate the mass percentage, or just the percentage composition of each of the compounds to 3 significant figures. So I have dihydrogen dinitride, and so the first thing that I need to do is find, and when I'm doing the percent composition, it's based on if I had 1 mole, what's the mass of each one. So I have to find the molar mass. So hydrogen, I have 2 times the atomic weight of 1.01, gives me 2.02. Nitrogen, there's 2 times, and the atomic weight's 14.01 to give me 28.02. I add those two together, and I get 30.04 grams. So the percent hydrogen then is going to be the mass of the hydrogen over the total mass times 100. So the mass of the hydrogen is just the contribution due to the hydrogen, which was 2.02. The total mass is the total atomic weight of 30.04 times 100, and I get 6.72. Same thing for the nitrogen. The percent nitrogen is the mass of nitrogen over the total mass times 100. And I've color-coded it so you see where the numbers come from. The mass of the hydrogen is 28.02. The total mass is still 30.04 times 100 to get 93.3. And as a check, I can add these two up because my total composition has to be 100%. So 6.72 plus 93.3 gives me 100.02. And that's just because rounding, it wanted the answer to 3 significant figures. So when I rounded this one to 3 significant figures, I added 2 extra decimal places. This one was actually 27, which would have made exactly 100. And so as long as it's close to 100 as your check, you're okay. All right, let's do a little bit more complex one. This is D of 58. Same problem. Again, I have to find the molar mass of the magnesium nitrate. So magnesium, there's 1 of them, and there's 24.31. Nitrogen, there's 2 of them, so times 14.01 gives me 28.02. Oxygen, there are 6 of them, times 16.00 to give me 96. When I add up the 24.31, the 28.02, and the 96, I end up with a 148.33 grams per mole. So again, the percent magnesium is going to be the mass of magnesium over the total mass times 100. So it's 24.31 divided by the total of 148.33 times 100 gives me 16.4. The percent nitrogen is actually the same as the mass of the nitrogen over the total mass. So 28.02 divided by 148.33 times 100 gives me 18.9. And the percent oxygen is the mass of oxygen of 96 divided by the total mass of 148.33 times 100. And so there's what the numbers put in, and I get 64.7. Again, as a check, I want to add up my 3 percentages, 16.4, 18.9, and 64.7, and I get 100, so that means that each one is correct. So that's your check. And that is the end of this